In the story, Things That Float and Things That Don't, you learned about density and flotation. The density of a substance is its mass per unit of volume.
I think I found the equation for it.
Yes, that's correct, Eli. Density equals mass divided by volume. In other words, it's the number of molecules in a given area. The more molecules you have in a given area, the more dense a substance is. So for example, we have some action figures here on a plate. This larger plate has a bigger area and there are 10 action figures on it. So the action figures are more spread out. This plate would be less dense than the smaller plate here with 10 action figures as well. If you notice, the action figures here are more crowded because they're in a smaller space. Therefore, they are more dense. In the story, there were a lot of examples of experiments with density and flotation that you could try at home. We're here to show you some more experiments that you could try at home, of course with your parents' permission. So this activity is called floating action figure. The question we're trying to answer is how much salt does the water need to make the action figure float? There are several materials you are going to need for this. You're going to need an action figure. You're going to need a mixing spoon. You're going to need a bowl. I recommend using warm water. You're going to need salt. And you're going to need some measuring spoons so you can measure out exactly how much salt you added to the water to make the action figure float. If you don't have an action figure, it works really well with a raw egg. Okay, so the procedure you're going to follow is first you're going to fill up a bowl with warm water. Go ahead, Gavin. And as you can see, the action figure sinks in regular water, but it floats in salt water. So I'm going to remove the action figure. Go ahead and take the mixing spoon, Gavin. And we're going to measure out salt. You also might want to have a science notebook handy so you can keep track of exactly how much salt you added to the water. So I'm going to start out with just a little bit of salt. And I'm going to measure it out and record how much I used. Okay, pour it in. Slowly mix it around. And keep mixing it until it dissolves. Okay. You can test your action figure and see if it floats. It still sinks. If it still sinks, you're going to need to add more water or more salt. Okay, so we'll add more salt and stir again until it's dissolved. Make sure you're recording your salt measurements every single time. You're going to keep doing this experiment until the action figure floats. So the science behind this is that adding salt to the water adds mass to the water and makes the water more dense. The more salt you add, the more dense the water becomes, allowing the action figure to float on top of it. So this activity is called hot water and cold water density. The question you're trying to answer is what will happen when we mix the hot water and the cold water together. Ask yourself, what do you notice and what do you wonder? The materials you're going to need for this activity are some mason jars. You're at least going to need 2. You're going to need some mixing spoons. You'll need 2 different colors of food coloring. You'll need some cold water and some hot water. You're also going to want to make a laminated index card. So what you can do to make one at home is take an index card or a thick cardstock piece of paper. It needs to be large enough to cover the opening of the mason jar. You take some packaging tape, go ahead and coat both sides, front and back, and you will have yourself a laminated index card. Okay, for the procedure for this, we're going to start out with 2 mason jars. Eli, my assistant, is going to pour hot water into both of these mason jars. I'm going to do this demonstration twice, so I have 4 mason jars. Very good. Safety tip right here, don't make the water boiling, but do make it warmer than room temperature. We're then going to fill the other 2 mason jars with cold water And I made ice cold water and removed the ice before we began. Now I'm not filling all the mason jars all the way to the top yet because we're going to need to stir in the food coloring. I am going to go ahead and color the hot water red, red for hot. Eli, could you please mix those in? And I'm going to color the cold water blue. Let's make that a little bit darker. And I'm going to mix the cold water. Very good, Eli, thank you. Now I'm going to top these off where I'm filling them all the way to the top for the next step. So fill it as high as you can without spilling it. Now for this next step, I'm going to take it over to a sink because sometimes it doesn't work out well and goes everywhere. So watch as I demonstrate the procedure of what to do.
Wait a minute. Did you forget something?
Yes, and you might need a towel because you might fail the first time. Put the index card on the top of the mason jar and watch as I do the rest of the procedure.
Okay.
As you notice, the hot water and the cold water do not mix. The cold water is more dense than the hot water, so the cold water stays on the bottom and the hot water stays on top. Now try this by flipping it around.
Folks, now we're gonna try this again with the hot water on the bottom and the cold water on top.
As you can see, if you look in at the color, you can see the red water moving up and you can see the blue water mixing down to show that the hot water rises and the cold water sinks. Eli, can you help me explain the science behind this to our friends here at home?
An interesting fact is that the temperature can change density. Molecules in hot water move faster than molecules in cold water. Hot molecules, water molecules, bounce around faster.
They leave gap between the molecules when it moves around faster. And cold water molecules bounce around slower, leaving less gaps between them, making them more dense. As you can see, the cold water remains at the bottom because it's more dense, and the hot water remains at the top because it is less dense. When we reversed this and had the hot water on top, you instantly saw the mixing of the hot and the cold water. The hot water began to rise and the blue water began to sink, making purple water. We colored the water so you could see this visual happening. So this is the Klutz proof density column. The question is,
why don't the layers mix?
so the materials that you are going to need, you're going to need a mason jar with a lid. If you don't have a mason jar at home, any clear container with a lid will work, like a water bottle. You're going to need a drop of food coloring. You're going to need water, vegetable oil, isopropyl alcohol, preferably 91%. If you don't have 91% and you only have 70%, we'll tell you what to do. And you're going to need non-iodized salt or kosher salt. You also might need a rag to clean up any messes. So the first thing you're going to do to create your Klutz proof density column is that you are going to pour equal parts of the three liquids, water, oil, and alcohol, into the jar. So you're going to also need some sort of measuring cup or measuring spoon for this. Gavin, are you ready to help? I'm going to pour, and you can go ahead and dump it in the jar. We're going to pour our water first. Next, we'll pour in our vegetable oil. And then we will pour in our isopropyl alcohol. Go ahead and hold that for me, Gavin. As you might notice, the layers are already starting to make themselves out. We're going to go ahead and put in a drop of food coloring to help us to see the layers. And we're going to put our lid on. Gavin, go ahead and give it a little shake. Now, as it settles, it will begin settling into 2 different layers instead of 3. And in order to see the 3 layers, you need to add salt. You're going to add enough salt to where when you keep stirring that there's a little bit left at the bottom. Okay, Gavin, go ahead and stir that salt in for me. And we're going to go ahead and add a little bit more. And then you go ahead and check the bottom and make sure that almost all of it's dissolved with a little bit left. If there's some left on the bottom, that's okay. And then what you're going to do is put the lid on it and be patient and let the layers begin separating out. When it's all done, you should have 3 layers that look like this. Now here's the science behind it.
It all comes down to density.
So after you wait about 10 minutes for your column to settle, you will notice that you have 3 distinct layers. And if you didn't get 3 distinct layers, it just means that you need to add more salt, stir it again, and go ahead and wait and watch what happens. So the bottom layer is our water layer, the middle layer is our oil layer, and the top layer is our alcohol layer. And like Gavin just told us, it all comes down to density. The water with the salt dissolved in it becomes our heaviest, most dense layer. The oil's the next dense, and the least dense layer is the isopropyl alcohol. So why add the salt? The reason we needed to add the salt is without that, you only got 2 distinct layers. We had to do a procedure called salting out. Isopropyl alcohol and water are both hydrophilic or polar molecules. Oil is a hydrophobic molecule. Without adding salt to it, the alcohol and the water combined. But once you add salt, the salt ions bind to the water molecules and you're able to see 3 distinct layers. So no matter how many times you shake this column up, it will always settle back out into its 3 columns.
For this next activity, we got a challenge for you at home. It's called Flink.
What's Flink, Eli?
Flink means, Dr. Gillette told me Flink means it doesn't float or sink.
So it just kind of stays in the middle?
Mm-hmm.
So do you mean neutral buoyancy?
Yes.
That's exactly what you mean. So for this challenge, you need to find an object and get it to not sink and not float in a body of water, but to stay right in the middle. You can use a large bowl, you can use a bathtub, you can use a sink, you can use a swimming pool. So be creative at home. Eli, what are the materials that people might want to use at home to do this challenge?
You could use styrofoam, bubble wrap, small action figures, small rubber balloons, rubber bands, toothpicks, pennies, masking tape, paper clips, and etc.
Yeah, the key to this challenge is to first find an object that can float in the water. So styrofoam and bubble wrap work great. After you find an object that can float in the water, you're going to begin weighing it down with different objects and get it to where it sits perfectly in the center of the water. So the science behind this. Neutral buoyancy occurs when the average density of the object is equal to the average density of the liquid that it's submersed in. So when an object floats in a liquid, there is a buoyant force that pulls upward on it, and there's the gravitational force that pulls down on it. When those two forces cancel each other out or are equal, you have neutral buoyancy, and the object does not sink and it does not float. It does what, Eli?
Thanks. We hope you had a lot of fun with these experiments of density, and make sure to try the challenge. Don't forget to like and subscribe to this channel and hit the bell and the notification box.
So make sure you take pictures of the activities you created and the challenge that you did, and post them on social media with the hashtag AVUSD Storytime Science. Thanks for joining us.
It's going to be like this, Eli.
Okay.
Start out with our hot water mason jar, and I'm going to place the laminated index card over the top, and I'm going to quickly flip it over and watch what happens. Okay, the index. Take two.
No,
Density column. The activity we're going to show you now is a Klutz proof density column.
The activity we're going to show you now is a... Oh, I can't say that.
Wait,
Go ahead.
Klutz proof?
You're doing great.
So, I can't forget it.
Okay, try again. The activity we're going to show you now is a Klutz proof density column.
The activity we're going to show you now is a Klutz proof. Klutz proof.
Density column.
A Klutz proof density column.
Do it again. Work very well, and then you can weight them down as you go. Enjoy these challenges, and make sure you post a cut.
You made me start smiling.
We're asking you guys to find an object and to get it to be neutrally buoyant inside either a bathtub, a bowl of water, a swimming pool.